Hello, welcome. Let's try to solve another Leetcode problem 1359 called all valid pickup and delivery options. So let me first try to explain the problem and then we're gonna find a solution to solve it. So the problem is that we are giving in orders. So each order consists of a pickup and a delivery service. So it's gonna first have the pickup and then we're gonna have the delivery. We just need to check how many permutations of the pickup and delivery. So if n equals to 1, it means there's one order. So first of all, we're gonna have a pickup first, and then we're gonna have a delivery. So this is like a real life. So there's only one case, right? But what if there are two orders? So if there are two orders, how can we count how many different cases? Let's just check the explanation. So as we can see, there are something like 6 different kind of combinations. Maybe let's just copy one of the combinations. So let me just copy one of the combinations. So for the first order, let me copy it as a P1D1. But if there are two orders, it's gonna be something like P1, P2, D1, D2. So this is gonna be one order. And how many combinations? It's gonna be one combinations, but if there are two orders, it's gonna be 6 combinations. Now we are also giving n equal to 3. If n equal to 3, let me just copy some code from here. So it's gonna be P1, P2, maybe P3 here. After that, D1, D2, and D3 here. So this is a D2. And D3. So this is gonna be on 3 orders. So this is 1, 6, and this is gonna be, let me check, it is gonna be 90. But for us, how can we get such kind of numbers? We may think about the problem. Maybe first of all, for one order, we're gonna put a P1 and D1. So what about there are two orders? So if there are two orders, it always depended on the first order. So for the first order, it is like this, P1 and D1. Now we're gonna put something like P2 and D2, just in between those orders. But where should we put it? So we're gonna put it together, because this P1 and D1 gonna be together. We put it there. So the next we're gonna put a P2 and D2, and there is a sequence for P2 and D2. So this means D2 always after P2. We can put P2 and D2 together, or we can separate them. But D2 gonna always be after P2. So for the P1 and D1, it is independent. But for P2 and D2, so for this D2, it must be after P2. So if we have this kind of a basic idea, normally we can solve the problem. So first of all, we're gonna put P2 and D2 together. So this is gonna be a P2, D2 together. This is one position, and in the middle there's another position, and after that, there's gonna be another position. So how many positions? 1, 2, 3. Now we're gonna separate P2 and D2, and this is one position, and this is another position, and this is the third position. So there are also 3 positions. So how many of them? There are 6 positions. So it means 3 plus 3, it's gonna be 6. But this is also like 3 plus 2 plus 1, it's gonna equal to 6. Normally we're gonna get this kind of a formula to solve the problem. But this is for one order, the result is 1. For 2 orders, the result is 6. So this 6 is dependent on P1 and D1, because there's one combination of P1 and D1, so the result is going to be 6 times 1. So it's going to be 6. Now we're going to check 3 orders. So 3 orders, normally, let me just remove those areas. So for one order, it is just a 1. For 2 orders, it is a 6. So for 3 orders, it depends on this P1, P2, D1, and D2. First of all, we're going to have a 6, because there are 6 combinations. And then we're going to time a number. So what kind of number going to be? So Similarly, for the P3 and the D3, this is a P3 and this is a D3. We can put them together as a whole part, or we can separate it. Yeah. So let's just check how many combinations. If we put it together, maybe we can put it here 1, 2, 3, 4, and 5. We can put it after that. Yes. So how many combinations? So there are 5 cases. Yeah. Now we can also separate them. Yeah. We can separate the P3 and the D3 as this. 1, 2, 3, 4. Yeah, there are 4 cases if we separate it like that. Yeah. So what about we just so what about we just put two characters in between? What's gonna happen? Let me just remove those areas. So if we put 2 characters P1, D1, we can put it like this. This is one. This is the second case, and the last one gonna be the third case. So there are 3 cases. So it seems it is something like 5 plus 4 plus 3 plus 2 plus 1. So it's gonna be 6 times 15. So what's gonna be the result? It's gonna be 90. Yeah. Now maybe we can find a conclusion to solve the problem, because this is just the formula. So what is the formula? Yeah. So the formula, we're gonna use the DFS. So for the DFSI, gonna equal to this is 6 is the DFSI minus 1. So this is gonna be the DFS I minus 1. Yeah, so it's gonna be the DFS I minus 1 for this is 6, and times, and this 15 is from 1 to 5. So this 1 to 5. So what about this 5? So this 5 is 2 times n minus 1. Yeah, so it is 2 times n minus 1. So this is the 5, and times 2n divided by 2. Yeah, so this is going to be the formula. So finally it's going to be n times 2n minus 1. So this n going to be 3. 2 times 3 minus 1 is going to be 5. 3 times 5 is going to be 15. So this is going to be the final result. Yeah, now we just need to use this kind of formula to solve the problem. So what about if DFS 2? So for DFS 2, it's going to be DFS 1 times n times 2n minus 1. It is n equals to 2. 2 times 3. Yeah, so this is going to be the final result. We just need to check. So the DFS I gonna equal to DFS I minus 1 times n times 2n minus 1. Yeah, we just need to have this kind of a formula to solve the problem. Yeah. Now let's just try to solve it. So I'm gonna use DFS, but before that, let's just use CAS and prepare a DFS. So inside I'm gonna prepare this n. Yeah. So if n equal to 1, so I'm gonna return a 1. Otherwise I'm gonna return, it means n gonna be at least 1. It's gonna be at least 2, 2 or 3. So it's gonna be DFS n minus 1 times the formula. So if I remember right, it's gonna be n times 2 times n minus 1. Yeah, so this is the formula. Yeah, so this is DFS n minus 1 times n times 2n minus 1. Yeah, so this is going to be a quite easy problem. I don't know why they set it as a hard problem. Normally it should be easy or medium problem, because I think most of us can solve it. Finally, we just need to return DFS n to get the final result. Let me just check. Yeah, so there are too many different cases, combinations to solve the problem. You can directly use the DP, or you can directly use the DFS, or you can maybe. Yeah, I think the DFS is much easier to solve such kind of a problem, because normally if it is a combination problem, so normally it should be a DP. And for solving the DP problem, normally DFS plus memorization going to be much easier to solve. Now let me just submit it. Yeah, because I forgot to use the mod. Yeah, because it is said the mod is going to be 10 to the power of 9 plus 7. Yeah, and the final result going to be modular a mod. And now let me put it inside the testing case and test. It seems it works. Now let me just submit it. As you can see, it works and it's pretty fast. And the time complexity is just O(n), and this n is 500. So even you set this n to be 5,000 or 50,000, it would always work. Yeah, because this is the time complexity is just O(n). It is a linear time because basically this is a mathematical problems. It is a combinatorics problems. Thank you for watching. See you next time.